Alright, let's try that again, but with my mic actually working this time. This is how my code works. I guess, well, if you clicked on this video, you probably know what it's about. But I used Python to build a tool to create pixel art in Minecraft. There are some sites that have similar tools that already exist, but there were just some features that I wanted that I couldn't find in other places, so I made it myself. It's very much kind of hackney, but that's totally fine. That's just how it's meant to be used. So I'm going to go over the basics real quick. Ignore my window here. So inside this folder, which I've called Minecraft Pixel Art, you have three main things. So first is bad block, and this is a list of every block image in the game that is difficult to get or that for whatever reason you don't want to use. Maybe it has a weird texture, maybe it's like what the glasses and they are transparent, or the trapdoors which are transparent, or maybe it's something that's physically impossible. If you were doing any pixel art for like a map or pixel art to be seen from up ahead, like from overhead, you cannot use the side of a crafting table because you cannot physically place a crafting table to put the side facing up, or you cannot use, normal standing up pixel art on a super flat world. You can't use the top of a crafting table facing sideways. It's just not possible. So this can help you sort blocks between different stuff. And I did not grab these manually. There is a way you can go into Minecraft and just take all of these files out of Minecraft by yourself. It's not that bad. I will link a video for that in the description, or if YouTube gets mad at me and doesn't let me put stuff in the description yet because my channel is so small, then I will just put it in a pinned comment. I will also put a link on how to download Python and get Spider. I'll put that in the comments as well, just in case you don't know coding or you're not into coding or you don't know how some of this works. But yeah, this is bad block, and then this is block. So these are the blocks that I like to work with, and it's possible to make an emerald block. It's possible to make an emerald farm, so you can get a lot of this really easily. The concretes, the terracottas. It's pretty easy to farm a lot of this, and the textures aren't bad. It's all very colorful, and it all is very, the texture is fine. So these are the ones that I like that work well. But you can go ahead and experiment. Like I made the codes that you can, if you say I don't want to have to farm amethyst blocks, you can very easily just take it, and now it's out here, and then just put it in bad block, and you're done. So bad block is literally just storage. The code doesn't touch it at all. It's just to stay organized. But everything that's in block, the code will actually loop through all of these blocks before it does anything else, and it will calculate the average RGB. If I could talk, that's like a tongue twister. It'll calculate the average color of every single block, and then it will use that to build the pixel art based on what you give it. Some of the blocks have an animation attached with them, so if that is the case, it will be bigger than 16 by 16 pixels. And if that's the case and you want to use it, right click and then what? Why is it not? Yeah, sorry. Right click, edit, and you're going to want to zoom in, and you're going to want to force it to be 16 pixels. So you can see in the bottom right here it says 16 by 16. So if you were to extend it, you'll see that it says 16 by 20. So you're just going to want to bump that in until it says 16 by 16. I'm not going to save because I didn't do anything meaningful. But there are a couple of blocks that are bigger than 16 by 16, and you're going to want to trim those up or else it'll break the code. So, like I said, you can do whatever you want. The big thing is that the block list right here, if you can't see, that is spelled lowercase, all lowercase, BLOCK. It does have to be spelled exactly because of the way the code works. And I'll get more into that later, but all you really have to know for now is that that has to exist. Now, the only other thing that has to be in this folder when you first start up and first start messing around with this program is just the block folder and the color extract. Now, this is built from, this is the third iteration. I could probably call it something other than Color Extract 3, but I'm lazy, so it's going to stay as Color Extract 3. Now, here's the thing. You can't just double click on it and open it. That does not work. You have to go to Spider and click Open, and from there, you can go through your normal file directory and choose the Color Extractor 3.0. And the reason for that is because this is a Python file, and Spider is the way that you view Python files, or it's my preferred way of viewing Python files. If you have a different way to view Python files and Python code, all the more power to you. But going back into here, we'll show you the last version that I made, and it's a Charmeleon. So if you double click on it, it'll open it up, and you can see, yeah, all this gray, that's stone. I believe this orange is orange concrete. And you can set the background to be whatever you want. Just know that if you have the background to be transparent, the code will just interpret that as white. It cannot handle transparency, which is a bit of a shame, but it's just a limitation in my knowledge and ability. And at the end of the day, if you don't want a background, you can just make it some awful weird color. So let's say I go in here. That's not how I wanted to do it. Let's say I click edit. That will open up the image in MS Paint. And from there, I can very easily just say, okay, let's just make it green, because Charmeleon doesn't have any green in him at all. So I'll make all of this background green. You just hit save, and then you can close out of Paint. And then the preview hasn't changed yet, but if we go back to Spider and we click Run, so notice here it says 005.png. That is the name of this image, right? So if we go into that and then we click Run, you can see it's kind of running in the background here. You can see some of my other attempts making sure it still works. And now from here, it'll actually spit out a little counter file. Now you don't have to get this right from here. It'll also save it in a different file, but that's how you know that it's done running. There's no errors. It just pops up, hey, here's the counter. Here's how many of each block you're going to need. And here it shows you these emerald blocks. Yeah, that's that green background that we just put in. So now you know just what it takes to make the character and just what it takes to make the background. So if you want transparency, that would be my. That's what I would do. Is I would choose a color that does not exist inside the main pixel art, and that makes it easier. So what this code will do is it'll spit this out, which just makes it a little easier to look at and use. But the best thing that it does is one, the preview. So you could work right off the preview if you want. I know when I first started doing pixel art, I would essentially do that, or I would go in and with paint and I would mark off and say like, okay, yep, I got that block. Okay, yep, now I got that block. Now I got that block. But we're going to exit without saving that. But that takes a long time. It takes a lot of thought. It takes a lot of effort. This build map that I have that it will automatically build, it works a lot better, I think. So it'll start off by saying, hey, this build map is for whatever image it is. So if you have these organized or whatever, you can run this code a couple of times in advance and have a couple of different things set up all at the same time. You just want to call it something other than build map. Because, well, I'll show you that. Well, I don't have to show you that. I'll just say it now. You're going to want to call it something else because every time you run the code, it will override this whole file. So this whole file will get deleted and then rewritten every time you run the code, which is totally fine. But this is what I really like, the layers here. So it'll straight up tell you, yeah, that first layer, it's just 59 emerald blocks. And it does that the whole way. And then when you get to layer 15 and things start getting complicated, it's a lot easier to know, okay, I placed 13 emerald blocks, then one black concrete, then 31 emerald blocks, then one black concrete, and then 13 emerald blocks. So it breaks this down for every single layer. And this is honestly really easy because you could even go through and just backspace the ones that you have done, or if you copy and paste this into like Word or something, you could highlight as you're going and just keep track of what layers you've done and what blocks you've done at that point. That way it's a little easier to do it if you have to break this into more than one sitting. Don't save. Now, what happens if you first start up? All you've got is the block list, maybe a bad block list, and then a color extract. Well, do you have to have these two built? No, you don't. You can delete them and it'll work fine. So we'll go ahead and go back into the code. We'll change it to 006 for Charizard. Hit run. Wait a couple seconds. Charizard's a little bigger, so it'll take a little longer. I'll go into the code a little bit more, but it will just take a bit. The larger the image, the longer it'll take to run. But it doesn't take super long. I could probably make it a little bit faster if I wanted to. But yeah, you see, if you delete the files, it just puts them right back in. So it'll either override what's already there, or it'll create a new one if it's not there. Now, the only other thing really to go over is, again, how to use it. So you've seen me update the name of the image. You do need the .png, so or .jpeg or whatever image it is. I actually don't know if it works in JPEG, so leave a comment to tell me if it can handle other types of images. I never even thought to check if it could do anything else because everything I've used it so far on has just been .pngs. Anyway, the main thing you want to mess with is these right here. So these are different values for colors and how it's going to calculate the average color of the block. So average bright, average bright is that will change how the code calculates the average color of a block. So this is getting a little bit more into color theory, which I had to Google when originally creating this code. But there's a whole bunch of different ways to calculate the average color of a block, or average color of anything. So based on what calculation method you want, you can change some of this. So basically, what average bright does is it'll change how you average the colors. Like I said, mess around with it, make it 1, make it 0, just do whatever you want. Now, lightweight here. Let me. Okay, so I searched my code, guys. That doesn't exist anywhere. That shouldn't make a difference on anything. So that's just gonna stay. Anyway, moving on. These guys actually do matter. So what they will do is they will boost, or you know, it'll either boost or downgrade how much each color is prioritized. And the reasoning for that is because our eyes can see differences between certain colors easier than we can see differences between other colors. So like red and green, we can see a lot more different variations in than we can see in blue. So you can try to adjust and match those up. I looked up some color theory and tried to see, okay, if I mess around with it, how's it look? What's it look like? And the reason I messed around with all this is because Wartortle has a kind of purplyish, lavenderish hue, and it was just coming out looking weird. So I was doing all these different things, trying to fix it, and it turns out I just didn't have enough purpley blocks in my block directory. So the more blocks you have available to use, the better it will look. Trust me. Um, but yeah, like I said, you can mess around with changing these from anywhere between 0 and 1. It does not matter. You could go above 1. That shouldn't matter because it's just multiplying by whatever these numbers are. So the main thing that I would say is that this point 0.1, point 0.3, point 0.6 is the color theory article that I looked up. That's what they recommended, but do whatever you want, mess around with it, see what gives you the best results. So yeah, that's how you use this code. Like I said, I'll be linking how to get those blocks out. I will also link how to download all the other stuff. If your pixel art doesn't have a border around the sides, top and bottom doesn't matter, but around the sides, you have to have at least a 2 pixel wide frame around, like on either side. So you can ignore it if you want. I think some pixel art looks better if you've got a frame around it or if you have like a background to it. but the build map that I showed earlier will not work properly if you don't have a thing on the sides. When I was doing my Pokemon, like I showed you before, I made sure to put 3 blocks of background on either side, just to on well not either side, on both sides, just to make sure there was good enough separation when I was doing pixel art of the Pokédex. So just make sure you have at least 2 blocks on the side, maybe 3 just to be safe, since that's what I did and I never had any issues with it. As long as it's more than a 1 pixel wide border around it, the code should work fine as far as the build map. But again, if you don't want to do that, or you don't want to go into Paint and edit some of the pixel art that you're making, that's totally fine. Just know that the build map may not be accurate at the ends of the rows. Now, for the big old nerds who want to see the inner workings of it, I'm going to go through it with you. Now, I'm going to be honest, I wrote this code months and months and months and months and months ago. You can see that I originally wrote it in October of 2022. And hey, guess what? I or I not I. It's getting close to October of 2023. So this code's almost a year old, and I have not edited it or looked at it other than messing around with these numbers since then. So I might hit a part where I don't fully know what's going on, and you know what? We are just gonna live with that. I'm also gonna take a little break to go get some water, which means I am gonna have to edit this video. The code starts every single time by looking at the blocks in that folder called block. I call it the block directory, and it will calculate the average color of every single one of these blocks. Now, the biggest thing I'm going to say is some of the blocks have an animation attached with them. So if that is the case, it will be bigger than 16 by 16 pixels. And if that's the case and you want to use it, right click and then what? Why is it not? Yeah, sorry. Right click, edit, and you're going to want to zoom in and you're going to want to force it to be 16 pixels. So you can see in the bottom right here it says 16 by 16. So if you were to extend it, you'll see that it says 16 by 20. So you're just going to want to bump that in until it says 16 by 16. I'm not going to save because I didn't do anything meaningful. But there are a couple of blocks that are bigger than 16 by 16, and you're going to want to trim those up or else it'll break the code. It won't necessarily break it, it's just going to make things look weird. And I'm going to have to edit that to be further in before people know about anything else. Anyway, so yeah, so it's the code starts by taking the average color of every block. So I just initialize the two. It doesn't really matter too much what's going on with them. Now, folder directory equals block. So that's just telling it where is it going to look for. So if you want to call it something other than lowercase b lock, be my guest. You just got to change it here. This should be the only place it matters. And that's going to be the red, blue, green values. 4 images in the folder directory, which is the block that we talked about earlier. That folder of all the different blocks. So it's going to loop through all those images. First, it's going to initialize the color. It's going to say, all right, reset everything back to 0, 0, 0. Then it's going to actually say, okay, where is the image at? Now first it's going to open the image, and then it's going to convert the image into RGB. So what that does is it's going to open the image and then make it something that Python can actually read and reference. It's going to get the width and the height. So I probably could have built something into it as that mentioned, like, oh, make sure it's 16 by 16. So it won't break the game. It won't break the game. It won't break the code. It'll just make your average look kind of. It'll make the preview look kind of funky if you don't, but it's not that big of a deal. Next, it's going to loop through every block, starting with the width and the height. So it'll loop through every X and Y. Now, inside of that, it's going to get the average colors total, so equals the, basically this is going to be a 1, 2, 3, red, blue, green in a list like this that we can say, okay, so average color red for the whole block is going to equal the total plus whatever, right? So my naming conventions don't make a whole lot of sense here. I'm going to be honest. I don't know what 1 year ago ZZNAP 1 was thinking, but hey, it works good enough. So this is kind of where it's going to be a little different. So um, depending on how you have the brightness values set up, it will either continually add on the squared color total, so it'll add whatever the red value is to the power of 2, or it will just add the red. So it's all about the way you're calculating the average color, like the average red value, the average blue value, the average green value. Um, Again, like I said before, mess around with it, see which one you like the best. So, you know, I preferred whatever was already up there, but you might think something else looks better, or maybe you're going to change it up and it'll be different for different pixel arts that you're working on. It's your art, so I really don't care. But then the best part here is where it just says append. So it'll take the name of the image, comma, the average color. So this is where, we got the average RGB in this already preset kind of list here. So we have the name, we have what the color it is. It's all neatly stored inside one variable that we can reference later. So next we're going to actually open the image that you specified up top. So this is going to be the actual pixel art you want to make. And the first thing it does to that is convert it into RBG. Same thing as with the blocks. It's just going to convert it into RBG. That just makes it something that Python can loop through and actually look at. We're also going to get the width and height, so they don't have to be the same sizes. They don't have to be the same sizes as your standard Pokemon sprite, so you can make it whatever size you want. Again, just know in Minecraft there is a build limit. You can only go up so high. Now, if you just go across the floor, you can make it as big as you want. But if you make it too big, it's just going to take a couple minutes for the code to run. It can't do everything instantly. It's only so fast. Anyway, you get the width, you get the height, and then you're going to make the build total. So this one is just used for creating the total counts of everything that you're going to need. And then you're also going to make a build map, which is actually pixel for pixel what block goes where. So after this is we're still in the initialization phase, so it's going to create the preview image that we showed earlier. And by doing that, it's going to also specify, hey, make this an RGBA. It's going to be a bunch of pixels. And also, it's going to be 16 times the width and 16 times the height. That's because every Minecraft block is 16 pixels. So when we're pasting in each image, like when we're pasting in each block, we want to make sure that it looks right. We're not overlapping blocks or anything weird, so we have to get this pixel measurement the correct. That's why I said some of the ones that have a different height than 16, they will actually overlap the block above or below them with that overhang, and it'll just mess up the way the whole thing looks. So I don't think it will break anything. It's just gonna make it look weird. Um, Pixel starting at -1, that's just the way I have my loop and my counters set up. I probably could have started at 0 and then added +1 at the bottom, but in my head it made more sense to do it this way at the time, I'm assuming. So I guess we'll just sort of go with that. Next thing, again, we're just looping through the height and width, the width and height. Same as we did before, just bigger because now it's with the whole pixel art. And then we're keeping track of what number pixel we're on. And now this test underscore D, I can tell by my notes here that that's the test distance. So like how far away it is from red, blue, and green. So pixel RGB is literally the pixel in your pixel art. And that is going to be equal to the RGB value at the X and Y of your pixel art. So this will be changing every time. Now, we've got the RGB of the pixel. Now we gotta get the RGB that most closely matches it. So now we're gonna loop through every block in the block directory again, and inside of here, we're going to test. Hey, this test distance is actually going to be equal to, hmm, wait, wait, what? Why is it like that? Uh, okay, I think this should just be 0. Why did I make it a list? What? Alright, let's make this just 0 and see what happens if the code breaks. Hey, look at that live editing, that works. So, okay, yeah. Basically, the test distance is just how close in color the block matches the test pixel. So the way that works is going to be the test distance. It's not really the distance, so I don't know how much you remember from math class, but like finding the distance between 2 points, x and y, is actually like the square root of the difference, between, it's like x1 minus x1 2 squared and plus the other one squared, and then you square root all of it. Yeah. All we're trying to do is minimize this distance, so we don't need to worry about the square root part. We don't care. So this is technically test distance squared equal to the red distance squared plus the green distance squared plus, if I scrolled, it'd be the blue distance squared. Right. So that's not that bad. And that's where these weights come in, right? So we can make you know, if we make it smaller, it'll care less about that weight. So this is where those come into play. Now, if we're on the very first block, it's going to say this is the best one, right? Because we need to have something there as a backup, right? If nothing matches at all very well, we got to have something to start the comparisons with. So if that's the case, we're going to start by taking the image you want to paste, and we're going to go into preview, and we're going to paste that image at the X and Y spots. And then we're going to take the total build, the pixel number. So it's going to say, hey, pixel 1 is whatever that block is. It's going to say build map at YX, so it's at the column and row. Make it that block. Now, real D equals test D. So I'm assuming real D is real distance and then test distance. Okay, so real distance is the current best distance. So that is going to be the distance of whatever block is the closest. So we want to store that so we can keep that for later. And then the next block in the loop will go up there, we'll calculate the next test distance. And if that distance is closer, if that's smaller than this real distance, right, then we know that that block is a closer color match. So that is where the magic really happens, is right here, is if it's smaller. And if it is, then we just repeat all of this stuff. So we paste it over top of the old one that was better, and we keep going with all the other stuff. So it'll loop through every block. Basically, it'll loop through every pixel and compare every pixel to every block. And then for every block, it will then, paste and save. And I probably could have done it in a faster way, like in a faster, like the code runs faster way, but I opted to make it the faster coding way, which is I chose the simplest solution, and that's what I stuck with because I'm not going to be making uber mega huge pixel arts. It doesn't need to be, a fast runtime. So Next, preview.save, all this does is save the preview image. So it doesn't care if preview is already a file, it'll just save right over top of that file, delete everything, it'll totally replace it. Next, C equals counter build total, print C. So I believe this counter, this is something that I didn't make, it's something that already exists, but basically it looks through your list and it'll count how many times everything appears in that list. So that's how you get the stone.png. So it goes through the entire counter where it lists out every pixel 1, 2, 3, 4, 5, or whatever, and it lists out stone, 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 and it'll count up how many times each name comes up, which is good. That's nice. So next, build map v2. I guess this is the second time I made a build map. I bet if I looked inside one of the older codes, I would have just build map and then comment it out. I'd have a build map 2 or something like that. So what this will do is it will loop through all of the pixels in the build. And how does this work? Oh, yeah. So this makes the build map. So it'll loop through, and basically I'm gonna, for I in range, yeah, okay, so I'm gonna loop through all of the rows in build map, then I'm gonna loop through all of the columns in build map. It looks kind of funky because Python's not great for matrices. So referencing in matrices kind of looks a little weird sometimes, and that's what's happening right now. But basically, block count equals 1. So the number of blocks in a group starts at right. Okay, so I'm trying to read my comments and figure out what's going on at the same time because, like I said, it's been a year. But this block count here will just calculate how many times in a row a certain block comes up. And then the group count will count how many groups you have in a row. And basically, I'm just keeping track of the group count to make it easier to do like to the length of and basically keep track of some of my loops and how things work. So next we're going to loop through all, like I said, loop through all of the blocks. So yeah, we're going to loop through all of the blocks in a row, and then we'll loop through all the rows, and each row you want to reset the total counts for all this stuff. Now, as we're looping through the row, if j is equal to the length of build map minus 1. And now the reason you have to do minus 1 is because if we're looking at the yeah. So we can't look at the end. So inside this code, the built-in references are looking at the current block and the next one. So we don't want to look at the, if our current block is the last one in the list, Python will throw up an error if we try to look at the next block in the list because it doesn't exist. So that's why we have to go to minus 1 instead. Now, block count equals block count plus 1. So if, wait, what? How does this work? Oh, okay. Yeah. So if we're at the end of the list, we know that this is the last one. So go ahead and add a block to the block count. Oh, Okay, yeah, so this is another weird one. I'll have to. Hey guys, I've had a revelation going through my code for the nerds, and if your pixel art doesn't have a border around the sides, top and bottom doesn't matter, but around the sides, you have to have at least a 2 pixel wide frame around, like on either side. So you can ignore it if you want. I think some pixel art looks better if you've got a frame around it or if you have like a background to it. but the build map that I showed earlier will not work properly if you don't have a thing on the sides. When I was doing my Pokemon, like I showed you before, I made sure to put 3 blocks of background on either side, just to on well not either side, on both sides, just to make sure there was a good enough separation when I was doing pixel art of the Pokédex. So just make sure you have at least 2 blocks on the side, maybe 3 just to be safe, since that's what I did and I never had any issues with it. As long as it's more than a 1 pixel wide border around it, the code should work fine as far as the build map. But again, if you don't want to do that, or you don't want to go into Paint and edit some of the pixel art that you're making, that's totally fine. Just know that the build map may not be accurate at the ends of the rows. So, yeah, if we're at the end of the road, then build map v2 of I, yes, so that's, yep, I group count. Okay, yep, that makes sense. That makes sense. So basically, we're doing the matrix, right? So we're at row I, group, whatever the group is, and that is equal to build map. Okay. Oh, yeah, I really should read my own comments here. It says for Pokemon stuff, the last 2 blocks will always be the stone, so I'm cheating here. For other project, I may need to get creative in terms of not skipping stuff on the side. Yeah, you can see how some of this is real hackneyed. Um, Now, what I'm doing here is I'm taking the build map at the current row, group whatever, so that's different groupings of like 5 stone or 4 concrete powder or whatever. And so we're setting that equal to the build map of I j minus 1. So basically we're taking at and looking at like, okay, so in the build, okay, I should specify there's 2 different build maps going on here. So I'll go ahead and open up the old build map. That's why there's a V2, right? So this build map does not separate them out. Every single block is listed in its entirety. And as you can imagine, going through and trying to count each of these was a pain in the butt. So that's why I made build map V2. So what this is doing is it's referencing the original build map at the same location, and it's saying, hey, if it's this block on the last one that we had an issue with, the j minus 1, because we still have to do j minus 1, whatever that is, add an x to it, and then add the count. So, and it has to be a string to make sure it prints properly, so you got to make it a count. And then why does my mic keep cutting out? Anyway, then you got to reset the block count and you got to increment the group count to be another one. So I don't know why I have to increment the group count if I'm already at the end. That seems redundant, but hey, it's not broke, so don't fix it. So else if we're somewhere in the middle, right? We're in the middle of a group. So if the build map at where we currently are is the same as the build map of the previous step that we were in, then that means the 2 blocks are the same. And if that's the case, hey, add 1 to the block count, check again. The next is if the current block that we're on, the current pixel, if that's not equal to the previous one, then hey, these blocks are not the same. So now we're going to actually want to separate it out. So we're going to make the group count. Yeah, so this is where we set it equal to, similar to up here. I don't know why I'm checking for the last case scenario first, but whatever. ZZNAP1 from a year ago was on something when he made this. Probably delirium or copium. Anyway, yeah, the build map is the build map of the current row that you're working on plus the group count of whatever group you're in is equal to, again, referencing the build map so we know the block, times the total number of that block, reset the block count so it can be used for the next row in the group, and then increase the group count to the next one so that we keep adding on to the groups, right? We're not overriding our own info at all. Now, this is where we are opening that build map text file for, and we're just writing in all the information. This is all fairly simple when you're first learning to code. The f.write, all these write stuff, usually you'll write into here, and you write out hello world and do all of that fun stuff. But yeah, basically we'll start by saying, this is a build map for whatever the image file is. Give it a few enters just to make it look a little prettier. Total blocks needed, give it another enter. So write in the total counters, that we print out here. So that'll go in there as well. Give it another few spaces. And then we're going to loop through every single row inside the build map v2. So for every row, we're going to... What? Oh, right. I forgot. When I initialized build map v2, I gave it there's a whole bunch of zeros in there. So now I go in and delete them later, but basically this goes from 0 to 2, whereas if I were to go to build map like the original, this has 80 and everything. So build map v2 originally would have been 80 in all of these. And I just initialized everything as zeros and then just replaced them as needed because that's kind of how I had to do it. I forget why, but I definitely know I struggled with that at some point. So I definitely copied this code from somewhere. I don't know where, but I definitely plagiarized this code from somewhere and just deleted all of the zero all the times that it was 0. But then I'm just gonna again for every single layer I'm looping through, I definitely copied this from somewhere too. This makes no sense to me, and it's not commented, so that means I copied it from somewhere. But basically, it's printing layer plus whatever. I don't know. Basically, this prints out the actual information as far as like how it's supposed to look. I showed you the text file, and then that enters it down to the new level for the next time we do the next row. So it'll start from the top and work its way down to the bottom. So I forget exactly how this works, but you know what? That's fine. I don't need to know how it works now because me a year ago knew how it worked, and that's all that matters. Okay, that's enough of my insane ramblings. Holy cow, my recording's been going for almost 45 minutes. We'll see how much that edits down to. Thanks for watching. If you have any comments, put them in. Well, if you have any questions, put them in the comments section. I barely do anything on YouTube, but I watch a lot of it, so I'll probably see those comments pretty easily. Those notifications should show up pretty regularly. So if you have any questions, I am more than happy to help. If I ever become not happy to help, I'll just not answer it. Or I'll probably add to the pinned comment, like, stop asking questions, I'm done. That probably won't happen because I doubt this will get popular. So thanks for watching. It's time for me to go edit this and then post it. Bye.